You can see here on my screen, this is the 7 segment display, and beside it you can see the pinout of 7 segment display. So there are two type of 7 segment. One is common anode and one is common cathode. So if I say 7 segment, it means there are 7 LEDs. So you can see A is the first LED, A, B, C, D, E, F, G. So there are 7 LED, all are actually compact together, and two pins are common, 3 and 8. So there are two type, as I said, common anode and common cathode. In common anode, this 8 and third pin will be positive and other pin will be negative. In order to glow these LED to other pin, you have to give negative voltage if it is common anode. But if it is common cathode, then third and eighth pin, which is common pin, will be negative. Rest all of the pins will be positive. Positive means if you give positive voltage to rest all of the pins, then only the LED will be turned on. So let's start the session. So I'm going to do this interfacing with register level coding, because if you do interfacing with Arduino function, then the program will be very lengthy. You have to declare each pin, and for each pin you will be writing 3 output, 4 output, 2 output, like that you will be doing. But here in this program we are going to use port D, which has 8 pins starting from 0 to pin number 7. So we will connect this 7 segment on port D and we will do register level coding, and for this we need a array. So we will use array also. So here you can see D0 to D7. So these 8 pins we are going to use in our program for interfacing this 7 segment module. So here you can see, if let's say I have to print 0, if I have to display 0 from 7 segment, then A, B, C, D, E, F, G. So A to F should be on, G should be off. Even H is basically DP, this is dot. So H we will not use, so H will be always 0. So for display 0, only G should be high, G should be low, rest all of the pins should be high, because I am going to use common cathode. Now let's take this. So as I said, H should be low and 0 should be low, and F should be high, E should be high, D should be high, C should be high, B should be high, and A should be high. So this is the hexadecimal coding. So we have to, what is the value of this? What will be the value of this? The value of this will be F. So this will be F, and what is the value of 0011? 0011 will be 3. So for display 0 we have to write, for 0 we have to write 0x3f. 0x means hexadecimal value, 0x3f, this value. So for 0 to 9 we have to write each value, so that we can make a counter which start from 0 to 9. So for 1, what will the value for 1? So for display 1, only B and C should be turned on, rest all of the pins should be turned off. So let's do this. As I said, B and C should be turned on, rest all of the pins should be turned off. So B and C will be on, rest all of the pin will be off. So what will be the value? The value will be 0x06, isn't it? It will be 0x06, because here you can see all 4 bits will be 0 and 000110 is 6. So 0x06. So we will just make a list of all of the things Then we will put this value in an array. For 2 A, B, G, E, D and C. A, B, G, E, D, right? Yeah, this should be high. So let's take these things here. Yeah, now it's okay. Now let's erase this part. Yeah, so for 2 what things will be high? For 2 A should be high, B should be high, G should be high, E should be high and D should be high. C will be 0, F will be 0 and H will be always 0. So what is the value? 4-bit and this 4-bit. So these from D0 to D3 is called LSB, lower significant bit. From D4 to D7 is called most significant bit, LSB and MSB. So 1011, what is the value for 1011? It will be B. And what is the value for 101? It is 5. So 0x5b, 0x5b, this is the value, 0x5b. So first let's write these three and let's see it is displaying 0, 1, 2 or not. So let's open this Tinkercad. Tinkercad is open. Let's take Arduino I have taken. Let's make the connection first. 7 segment, let's pick from here. So if you write 7 segment, you can easily find that. Yes, so let's pick this one, and you can see this is common cathode. You can select here common cathode because we are going to use common cathode only. Let's make the connection quickly. This is required, so I will connect a resistor to this leg and then I will just do ground. First A should be connected on pin number 0, B should be on pin number 1, C should be on pin number 2, sorry, then D should be 3, E will be here, E should be on pin number 4, F should be on pin number 5, G should be on pin number 6. H we don't need to do connection, we can do if you want, otherwise you can leave also. All connection are done. Let's write the code. So we have calculated the 3 value only. So first let me delete all these things. We are going to do register level coding. First let's create an array integer LED. I have only taken 3 value, so let's write 3, 0, 1, 2. It will start from, array will always start from 0. So what is the value of 0? 0x3f. Then what is the value of others? Let's see here, 0x06 and 0x5b. 0x06, 0x5b. Only we have written these value. Void setup. First we will check these things is working or not, then we will write for 9 till 9 also. Void setup. Here what we will do, ddrd equal to 0xff. So I have defined port D as output. So if you don't know the register level coding, please watch my previous video. I will add that link in description. While loop, that's it. It is very simple guys, only you need to write 5 line code for printing the value of these things. Now I will just do for integer, I will just create a variable integer I, then I less than equal to 2. I will start from 0, then I plus plus. Because I have taken only 3 value, that's why I am running this loop 3 times. And inside the for loop I will just do port D equal to LED I. That's it. Let's put a delay also for 1 second so that we can see. Delay spelling is wrong. Let's correct that. Delay. Correct. Everything is done. You can see it is very simple. Now let's see what is printing. Let's simulate. This is wrong. Integer LED 2 3 for integer 0 1 2. Oh, let's we have to change 3. Now it's correct. Now you can see 0 1 2 0 1 2 0 1 2, right? Because we have put it till 3 value we have given, that's why it is displaying 3. So let's say we have to increase, let's say we have to now display 3. So what will be the value? So same thing, what you can do, just let me erase these things. For 3, which pin should be high? For display 3, A, B, G, C, D. Only except E and F, every pin should be high. So except EF. So let me do EF 0, and rest all of the pin, even H will be always 0 as I told. Rest all of the pin will be high, right? So what is the value of this? Hexadecimal value F. What will be the value of this? This will be 4. So for 3, 0 x 4 F, 0 x 4 F. That's how you can do for 4 also. For 4, what will be the value? For 4, the value will be, for 4, F, G, B, C should be high. So F, G, B and C should be high. Rest all of the pins should be low. H should be low. Now what is the value? 4 bit. This is what? 6. Again this is also 6. So 0x66, 0x66. Now I think guys you got an idea how to do these things. So you can add on till 9. I will just show till 4. Hope you got the idea. So let's put the value for 3 and 4, 0x4f and 0x66. So let's come to the code. So 2 more thing we have added. 0x4, what is the value for 3? 0x4f, 0x4f, then 0x66, 0x66, correct? Yeah. So now we have to change these things because we have added 5 element now. So 5, and we are going to run these things starting from 0 1 2 3 4, and then everything is correct. Let's simulate now. 1 2 3 4, 0 1 2 3 4. So as you can see guys, this is very simple, but if you use the Arduino function, the program will be very lengthy. It will be 20 line of code, and using register level coding you can minimize the code. Even the execution of the program will be very fast if you use register level coding. So I hope you like this video. So if you like, please hit the like button and subscribe my channel. Thank you.